In this question, there are two pulleys. One is fixed pulley and another is um, movable pulley. And there is a ball and there is a rod. This rod and the end point of this rod and the ball are at the same height. Okay. And the question is, if the mass of the ball is eta times mass of the rod, and that is mr, then find out the time in which this ball will cross this rod, right? We have to find out that. Let's do that question. Okay. Now you can see from here that this pulley, if it goes down by certain amount, let's say this goes down by certain amount x. Now if it goes down by certain amount x, this rod will go down by a certain amount 2x. Why? Because see, if this has gone down by x, then the string has been increased by 2x amount. Here this is a reduction of x, here also there is a reduction of x, so this will increase by 2x amount. Here the string is fixed, right? So it will become 2x. Now the ball will go downwards or upwards. The ball will go upwards because the pulley has gone down, so this ball will go upward. But now the ball will go upwards by x amount. Why? Because this pulley is attached to this string, so the string will go upwards by x amount. The acceleration of ball, if it is a, the acceleration of rod is 2a. So I double differentiated this distance, this displacement, so the 2x and x. Okay, right. So now let's draw the free body diagram. If the tension over here is T and the tension over here is also T, then the tension in this string will become how much? See, here there is a tension T, here the tension is T. So this is T. Then since this pulley is massless, this tension has to be 2T, right? So here also the tension is 2T. Now for the ball, let's write for the ball free body diagram. What will be the free body diagram? So let's use a different color. For ball we will use green. The upward force is 2T. Downward force is ball has mass mb, so mb times g, and the acceleration is upwards, so the acceleration is a. So this will be 2T minus mbg is equal to mb times a. So I am first finding out the acceleration, then we can use the concept of relative acceleration to find out how much time it will take for the ball to cross the rod, right? Now for the rod, what is the situation? For the rod, this is mr times g minus t. The tension is upwards, right? So I will draw the rod's free body diagram like this. T is upward force, rod has mrg weight, and the acceleration is downwards, which is 2 times a. So this will be mr times 2 times a. This is the second equation. Now what we will do, we will multiply this both sides by 2 for this equation. So multiply by 2, we will get I will add these two equations now, then you can cancel 2t. So this will be 2mr minus mb into g is equal to 4mr plus mb into a. This will be the acceleration. Now mr is mb is eta times mr, so I can write eta times mr here. Cancel out mr by dividing both sides by mr, so this will be 2 minus eta upon 4 plus eta times g is equal to the value of the acceleration a, right? So this is the value of acceleration a. So ball will move upwards with this acceleration and the rod will go down by the acceleration 2 times of that of the ball, right? So the relative acceleration will be 3a. Why it will be 3a? Because rod's acceleration is downwards 2a and ball's acceleration is upwards a. So the net acceleration relative to the rod will be 3a for the ball, right? So according to the rod, this ball is traveling with the acceleration 3a, right? Okay. Now what length has to be covered by the ball? The length L has to be covered. So initial velocity was 0 because they started from this. So the displacement is L. So you can use S is equal to ut plus half. Now the relative acceleration to be written here is 3a t square. U is 0, so S is equal to half into 3a into t square. Now S value is L, so I will write 2L by 3a with the square root as equal to t. Now t will be equal to square root of 2L upon value of a is 2 minus eta upon 4 plus eta. This is the g. So this is the time it takes for the ball to cross this rod. So this rod will be crossed by this ball in this much time.